Hi everyone, today I'll be teaching about Single Accumulator Organization. Single Accumulator Organization is one of the three register set organizations along with General Register Organization and Stack Organization. In Single Accumulator Organization there are 8 general purpose registers and multiple of 8 plain registers. We'll see those 8 general purpose registers in detail. The first is program counter. Now we'll assume that we are using a system which has 12 bits of address lines and 16 bits of data lines. So the program counter, it holds the address of next instruction to be fetched. Suppose there is a branch instruction, the controller program branches to another location, then program counter is used to tell the computer where to come back to, where it starts executing again. So the program counter, since it holds the address, so the size of program counter in a hypothetical system would be same as address part, which is 12 bits. Now the second general purpose register is address register. Now address register, as its very name suggests, is used to store addresses. What happens is that the system will get an address in the address register. It will go to the memory, and from that address it will pick up whatever is there. If it is a data, then it will be stored in data register, and if it is an instruction, then it will be stored in instruction register. So address register, it would be 12 bit, same as program counter. Data register, since it is stores data, it will be 16 bits. Instruction register, it is also data, so it will also be 16 bits. Now the fifth general purpose register is the most important, which is accumulator. Now the accumulator, it holds the partial output. What that means is all the arithmetic and logic operations will be performed with one of the registers would be accumulator, other could be someone else, and the result will always be stored in accumulator. It will hold the partial output. After final instruction, it will hold the result. Since accumulator has data, size of accumulator would be 16 bits. Next is temporary register. A temporary register could hold either data or address temporarily. It deals with both data and address, so the size of temporary register would be maximum of the size of either data register or address register. Since here data register is 16 bits, which is more in size than address register, so the size of temporary register would be 16 bits. Now the last two registers are input register and output register. Input register accesses the input from the user and sends to main memory, whereas the output register, it sends the data from main memory to output register, which means output register to peripheral devices. Since input register, output register work with peripheral devices, and all peripheral devices work on ASCII codes, which has 256 character, which means only 7 digits, but smallest measuring unit of storage is 8 bits. So the size of input register and the size of output register would be 8 bits. So these are the 8 general purpose register in single accumulator organization. A single accumulator organization can also have plain registers, but those plain registers would always be in multiples of 8, as in R1 to R8, R1 to R16, R1 to R32, etc.